A question was asked about Chapter 6, Question 19, which has to do with determining the percentages of D and L isomers in a mixture of that contains both D and L enantiomers. So in this case, what they say is that the specific rotation of L-DOPA, and L meaning levatory means that this would have a negative sign, negative number of degrees, that the specific rotation for a pure L-DOPA solution is minus 39.5. That also means that then that the specific rotation of D, a solution of pure D-DOPA, would be plus 39.5 degrees. Okay. So the L and D dopas, L for lever rotary, which would be negative, D for dexter rotary, which would be positive, they have the same number of degrees, just opposite directions. And what they're saying is they have a mixture that only has a specific rotation of minus 19.75 degrees. Okay. Now, what can we conclude initially from that value? Well, since the specific rotation of the solution is negative, what that means is the major enantiomer of this solution is the L form, because it has a negative sign overall. Okay. Now what we've got to do is we've got to figure out what the percentage of D and the percentage of L is. And in order to do that, we're going to need to talk about what's called the percent enantiomeric excess. So the percent enantiomeric excess is basically the percentage of the major enantiomer minus the percentage of the minor enantiomer. Here's an example. Let's say I had a 75% mixture of the L and I had a 25% mixture of the D. And those 75 and 25 add up to 100, which they should. So let's say we had a 75-25 mixture of L to D enantiomers. The percent enantiomeric excess would equal 50. So we'd say that that solution has a 50% enantiomeric excess. Now, if we look at the words here, that means that the major enantiomer is 50% in excess of the minor enantiomer, which is exactly what 75 is to 25. Okay. So if you had a racemic mixture, and remember, a racemic mixture is 50% of L or D and another 50% of the other enantiomers, so it's a 50-50 mixture, you would have a 0% enantiomeric excess. And of course, if you had 100 to 0, you would have 100% enantiomeric excess. So in this case, what we have is we have to figure out what the percentage of enantiomeric excess is for this minus 19.75 degree solution. And so the easiest way to do that is to say, well, if I have a solution that's minus 19.75 degrees and the pure solution has a specific rotation of minus 39.5, if I take the ratio of those and multiply by 100, that's going to give me the percent enantiomeric excess of the mixture. And so if I do that, I'm going to take minus 19.75 divided by 39.5, I get a 50% enantiomeric excess. Now, I didn't actually do the math, although the math is, looking at it, minus 19.75 is exactly half of minus 39.5. But the example I showed, I didn't do the math ahead of time, so this is purely coincidental that it turns out to be 50% enantiomeric excess. But let me just show you with the 50% enantiomeric excess how we would solve the problem if it wasn't 50%. The fact that it's 50% means that we have a 75-25 mixture, so that they're asking what the percentage of L-DOPA was in the solution. Well, it would be 75% L-DOPA and 25% D-DOPA. But let me just kind of finish this problem out, because you might say, well, what if the math didn't turn out nice like that? Here's what we would do. We have a 50% enantiomeric excess. Here's what I know. I know that the percentage of the L isomer plus the percentage of the D isomer has to equal 100. That's equation number 1. But in this case, the percentage of the L isomer minus the percentage of the D isomer equals 50%. Okay, and so this would be my percent EE of my mixture, of any mixture. So I have two equations and two unknowns that I need to solve. And there's lots of ways to solve this equation. I mean, the easiest way to solve those two equations is just simply to add them. So if I add them together, I get 2 times the percent of the L enantiomer, the plus percent D and minus percent D add up to 0 equals 150, which again would, this in any problem would equal 100 plus the percent enantiomeric excess. And so now dividing by 2, I now have that the percentage of the major enantiomer equals, in this case, 150 over 2, which is 75. So the percentage of L, the percentage of the major enantiomer, is equal to 75. So what's the percentage of the D enantiomer? If L and D have to add up to 100, it would be 100 minus 75, which would equal 25. So this mixture is 75% L, major enantiomer, 25% D, which is the minor enantiomer. And so we can use these two equations to calculate the percentages of any enantiomeric mixture if we know what the percent enantiomeric excess is. And how do we know the percent of enantiomeric excess? The percent of the enantiomeric excess is simply equal to the rotation of the solution over the rotation of the pure. And the sign of the major enantiomer comes from the sign of the overall mixture. Okay. And we'll talk more about this in terms of calculating percent enantiomeric excess. You actually are going to do this in lab towards the end of the semester. So that's how you do a problem like that, and that includes the equation on how to do it for really any kind of mixture that you have.